Welcome everybody. In this lecture, we will be talking about the cost of beneficiation process, that means the processing of ore, and overall environmental impact and the cost for mitigation. These two topics will be discussed, and the concepts that we will cover in this lecture are the beneficiation cost, certain case studies to understand the different components of the beneficiation cost, different stages of mineral beneficiation and their cost breakups, environmental impacts of mining operations, and then the factors that affect the capital expenditure in environmental management, because there is a mitigation cost involved, and also the factors that affect the operating expenditure in environmental management, that means both the capex and opex. And the strategies for reducing environmental cost will be added as a suggestion in the end of this lecture. As you are aware that the mineral beneficiation follows the production for the purpose of improving the grade, or we concentrate the value mineral of the ore and the quality of ore by removing unwanted impurities from the ore that we produce from a mine. But in coal also we do coal washing, and different processes are involved to improve the commercial viability of the mineral or coal that we are processing. The process will definitely enhance the economic value by making it more suitable for industrial use and metal extraction, as the case may be. So, what are the key objectives of this mineral beneficiation process? We enhance the ore quality by removing the impurities like silica, alumina or other gangue minerals. We improve the economic value because higher grade ore will face better prices. Unnecessary dilution with low grade will definitely reduce the price. And the sustainability and environmental impact because of reduced energy consumption in smelting and refining. When we are sending the high grade concentrate, then we use less energy to extract the metal from the concentrate instead of processing the entire thing in the final stage. So, how do we start? Say we produce the ore from a mine. Big size boulders or big rocks are there, definitely the entire thing is not crushed to smaller particles in the mines. So, the first thing is that we need to reduce the ore sizes to facilitate the further processing, like say we call it a size reduction, or in general comminution. The comminution process is a stage by stage reduction in size, not just from big to very small. There are different processes involved. Like say in primary crushing, like jaw crushers or gyratory crushers are used for breaking down the large rock fragments to break down the large rock fragments to smaller one. Then secondary and tertiary stages are crushing are further, they also bring down the size to make it suitable for feeding to the grinding mill. The grinding mill is that process the small pieces of rock into fine particles, and the idea is to reach the liberation size when the value minerals are almost physically separated from the gangue minerals, so that they can be processed to remove the waste effectively, and we can collect the value minerals from there. Now, at every stage of crushing, as you see that we are reducing the size. So, there is a target size. So, if we use a screen, then we can classify that the oversize and undersize we can classify. The undersize goes to the further process, and the oversize, that means sizes which are above the desired size, that will go back to the previous stage, and again it will be crushed or ground to make it to bring it down to the right size. Now, the processes are like we use vibrating screens for classification, or also we used for hydrocyclones for weight classification of finely ground ores. Then we come, once we reach that very fine the particles where the value minerals can be now separated, then it goes to the concentration process. So, either we can use gravity separation, or say spiral concentrators, shaking tables. These are examples of gravity separation. And for magnetic separation, we have high intensity magnetic separators for iron ore. In flotation, we use the chemical reagents for selectively separating the valuable minerals. The value minerals will say float, and the other part sink as the process is designed. In leaching, the chemical dissolution of metals is done. Say for example, cyanide leaching for gold. So, if you use the chemical, then the value mineral will be leached, that means will be liquefied as another and then it will come out. Then we can process to take out the gold. So, the in copper mining also we use the leaching process in certain cases. Now, after that, when you take out the value mineral or rather the concentrated part, then there will be certain waste material, we call them tailings. So, tailings will be reject as waste, and the enriched ore is called the concentrate. The concentrate will have lot of moisture or water in it. So, what we do, that first we need to thicken this thing, that means we feed to a thickener in which the water will be going up, because the material try to settle down at the bottom of the tank, and the water will be above that slurry. So, what we do, we collect the slurry from the bottom of the thickeners, and this is further processed in filtration unit. The purpose of using the filtration units like the vacuum filters or pressure filters is to achieve dry cake. That means, we try to remove the moisture as much as possible. Then we stack it for further transport and metallurgical process. And the tailing part, what we do, that this is a waste material, fine, but in many cases or most of the cases we try to use this tailing material for the purpose of filling, backfilling in underground mines especially, or otherwise the excess material whatever is not utilized by backfilling will have to be stored in a tailing dam. It is called tailing pond, or you can use dry stacking, which is nowadays has become very popular. Let us take a case study on the cost involved on this process. So, for a beneficiation plant of capacity which can handle 3 million tons per annum for copper ore, we can use one gyratory crusher to handle this ore as a primary crusher, followed by 2 jaw crushers and then 2 cone crushers. Then we can use 4 ball mills in line and other essential flotation cells for beneficiations. Now, here we are using the gyratory crushers as primary. So, from there at that place we are feeding the ROM, run of mine, and then it is gradually getting reduced in size, unless and until through the ball mills we get the fine particles. After that, as I said before, that we use the disc filter or ceramic filter for drying the concentrate, that means reducing the moisture content from the concentrate. So, there will be thickener for further process, and the tailing pond where we dump the tailing, store it properly. In this case, the feed size is 2 feet around, that is ROM size rocks, and the ball mill can accept 6 millimeter size ore as feed. The output of the mill is expected to be around minus 200 mesh, and the feed grade of the chalcopyrite is a 1.2% copper. So, the concentrate grade is expected to be 25 to 26%, that means from 1.2% to enriched 26%, and overall recovery will be 93% in the total beneficiation plant. Now, this is a specific case study where we have taken it from certain sources, and we are just trying to understand the cost involved in the installation and running this kind of beneficiation plant. So, we need to estimate the cost just because in DPR when you prepare a detailed project report, the beneficiation has to be thoroughly detailed and the cost involved is required for estimating the capital cost or operating expenditure of the plant. So, in this case a cost breakdown of the equipment and associated cost along with the installation and operating expenses are shown here. These are approximate, it can vary also depending on specific requirement, suppliers or even the market conditions. The cost might change over time, but at present we have these figures for you to understand what could be the cost involved. We have said we will be using gyratory crusher, one crusher which will cost us around 5 crores, and jaw crusher we will use 2, so that also will cost us 2.5 crores each. Cone crusher 2, so we have 3 crores each, and that will cost us 6.0 crores. Ball mills we need 4, as I said. So, here we have designed 4 ball mills, one may be idle, 3 may be running. So, in case of breakdown we can run the other one, like that we have designed here. These are design assumptions, there could be variations depending on the person who is designing it. So, say 16 crores will be there, then the flotation cells about 10 crores in line, and then disc filters we are using here which will be costing us a 2.0. This is for the purpose of drying the concentrate, to taking out the moisture from the concentrate. Similarly, we can use ceramic filters which will cost us around 3.0 this year crores, and thickeners for removing the water in the beginning. So, the 4 crores will be spending for that, for solid liquid separation natural, and the settled material will be sent to the the disc filters or ceramic filters. Now, the tailing ponds is will be costing us around 5 crores, that is in the beginning. It may be much more than this depending on the size and the geographical condition or the terrain, how much you require to invest for making the embankment, which could be big investment in the beginning. And auxiliary equipment, as I said, in pump, conveyor, this and this, all these things will cost us another say 5 crores. Infrastructure, the plant structure, all these the sheds and the structures, there will be requiring at least around 10 crores for site development, building, utilities. Contingency is just taken as a lump sum, 10% of the entire cost. This is to cover the unforeseen expenses. So, total capital expenditure will be here around 78.1 crores, 78 crores. This is the figure coming now. As an example, so installation cost typically account for around 20 to 30% of the total equipment cost. Assuming 25%, it is coming as 19.5 crores for the installation purpose. Now, the operational expenditure, once you have installed, then we are thinking about the operational expenditure for processing 3 million ton per annum. So, all the labor cost, energy, maintenance, consumable, chemicals, all these things will be required. So, labor cost we are taking rupees 50 per ton, energy rupees 150, like that. So, it is coming total operational expenditure is coming around 260 rupees per ton. This is quite reasonable, and annual operational expenditure rupees 260 per ton, and for the total tonnage, if you have 3 million tons, then it is coming 78 crore per annum for the entire operational expenditure. Now let us combine the capex and opex part. So, if you are amortizing this capex, that means if you are dividing the capital expenditure over the life of the mine, which is estimated to be 20 years lifespan, then annually we will be spending around 4 crores per annum. Means we will be dividing this as if we are spending the same amount of money over a period of 20 years. Remember that we are not using the time value of money concept in this particular exercise, that will be separately taught, and there these figures will change, because over the 20 years the time value concept, when it is applied, then these figures will change. But let us have at this present as if it remains constant, assuming that. So, the total annual cost, annualized capex and annualized opex will be the rupees 3.9 or 4 crore plus 78, which comes roughly as 82 crores. So, total cost per ton will be coming to rupees 273 per ton. There are reports where the cost is slightly higher, or depending on the efficiency of machines or the quality or the design of the plant. The modern plant, the cost could be less. But remember that now the switching over from one system to another system is sometimes not always, the new machines are not always compatible with the old machines. But there are certain things, like in place of disc filter you can use these ceramic filters, so that will make it more efficient. So, like to summarily what we can say, that the total capital expenditure is about 78 crores and installation cost is 19.5 crores. So, operational expenditure is 78 crore per annum and the cost per ton of ore processed will be 273 rupees per ton. So, that we can find out from the. So, it is a case study that gives you an idea of what could be the the cost per annum for the purpose of installing a beneficiation copper ore beneficiation plant, and that will process 3 million tons per annum. So, giving the example of say the mining process or beneficiation process, we are coming to an important part of the mining operations, that is the environmental impact of the mining. So, as we have repeatedly we have encountered this the problems that is created due to the industrialization. So, in mining definitely we are likely to cause air pollution, dust emissions due to blasting, drilling and material handling. There will be greenhouse gas emissions also from the diesel powered equipment. There will be release of particulate matters and toxic gas even from the blasting also, SOx, NOx, all these things. For mitigation measures, we need to have dust separation. Here the cost is coming, that how we are mitigating the environmental impact. So, dust separation using the water spraying or chemical binders, and we are switching to say electric or hybrid mining equipment. So, that can be that will reduce the diesel emissions, and your installing air pollution control system, back filter or scrubbers. So, that will reduce the your impact, environmental impact. So, these are important mitigation measures. In water pollution, the acid mine drainage is very well known due to the oxidation of sulphide minerals, and the contamination of surface and groundwater is also with heavy metals. Excessive water usage leading to the depletion of local water resources, that is another issue. Now, the mitigation measures are for the water pollution. We have to construct the tailing ponds with proper lining, so that the water does not come out and then contaminate the water bodies around or the agricultural land around. We have to treat the wastewater before we discharge, so that it does not cause any harm, and we implement the water recycling system, so that the water cost is reduced and the water can be conserved, the conservation of the water, and we can reuse this for the industrial purpose by recycling the water that is discharged from the plant or the mine. Mining also causes land degradation, habitat destruction, soil erosion or subsidence in case of say caving operation, or underground mining operations. In coal mining also there is subsidence. In caving operations, it's intentionally, we know that there will be subsidence on the surface, it will cave in. So, what are the mitigation measures connected with this? So, we have to go for land reclamation and afforestation. We have to again plant trees where we have caused deforestation. We have to backfill the open voids created in open pits, and for the stability of the the dam, overburden dams or the backfilling, wherever we are doing, we try to stabilize them using say for example geotextiles to prevent. All these things will incur cost. So, here we are now going to certain things which are necessarily produced in the mining operations, other than the dust and the water pollution, we also have noise pollution, vibrations. So the impact is, from the drilling, blasting, ore transportation, there will be huge noise continuously throughout the operating life. And during blasting also we cause lot of vibration that will affect the nearby communities and also wildlife. The sudden shock will scare the wildlife away from their natural habitats. What are the mitigation measures that we can take? We can implement the control blasting techniques, so that the noise is less and the vibration is also less. We can put noise barriers to see that the noise is absorbed before it is further transmitted into further away places. We also have the problem of biodiversity loss because of the destruction or disruption of the ecosystem or wildlife habitats. So there will be fragmentation of the forest because we are making roads through the forest. The forest is now divided, so the continuity is gone. So what are the mitigation measures that we can take? We can establish biodiversity offset programs, creating wildlife corridors, so that we can support the to maintain the ecological balance. Now, what are the factors that affect the capital and the operating expenditure for environmental management system? This environmental management system is nothing but those systems that are implemented and operated for mitigation of the environmental adverse impacts, like say tailing storage facilities, mine waste dumps and landfills. In water treatment, we have effluent treatment plants like the we call it ETP, the initial setup of the chemical and biological treatment plants for mine water, and also the acid mine drainage water treatment, installation of limestone based neutralization to reduce to neutralize the pH, acidity, and bioremediation system. All this will cost in the installation of plant and operation of the system throughout the life of the mine. Even when the mine is closed, then also you have to make arrangements so that the tailings or the backfills, whichever we are dumping there or leaving, that should not cause any environmental harm in future. That we must ensure before leaving the place. So in air pollution control, we have to install the dust separation system, emission control systems, and for land reclamation and biodiversity conservation, we need to follow the mine closure planning, and mine closure cost is involved. So in progressive rehabilitation and implementation of the progressive mine closure plan, we have to see that the fund that has been allocated has been properly utilized to see that the progress is uniform. That means in tune with the progress is mining. We should not lag behind in that. So the cost will be throughout the life of the mine, you have to go on spending, and when the mine is closed, all your actions should have been completed by that time. So the also we have talked about the biodiversity protection measure like the wildlife corridors, the afforestation, all these things. For noise and vibration control, the control blasting technique. So we need to spend in scientific studies, and we must use proper efficient blasting softwares, blast design softwares, and low explosive impact materials to control the blast noise and vibration. Now we will take a case study where about 3 million ton per annum open cast copper mine and a beneficiation plant, assuming the life of the mine is 20 years. So the environmental cost, we have taken these figures from certain consultants, and what they said is that the waste management infrastructure will cost you around 75 crores, and the operating expenditure of the waste management infrastructure will be 2.5 crores per year. Similarly, we have figures for water treatment system, 2 crores per year, air pollution control 1 crore per year, land reclamation and biodiversity about 1.5 crore per year, noise and vibration control we have around 40 lakhs, tailing dam management system and disposal is costly, is 3 crores per year, environmental compliance and monitoring we have some 70 lakhs here. So, total estimated value for the the capex is on the in the middle column we have the capital expenditure for installation establishment of the facilities that will cost us around 330 crores over which can be utilized for the for 20 years, and the operating expenditure will be around 11.1 crore per year. Now, if you transform this or reuse these figures and then distribute these figures per ton, then we can arrive at a conclusion that per ton of ore processed or produced, how much are the environmental costs incurred or you have to spend. So, for environmental OPEX per ton of ore processed, we can take the annual operating expenditure as 11.1 crore as we have shown in the previous slide. We know the production 3 million ton. So, dividing that, it comes around say rupees 37 per ton. When we are combining the capex and opex, the annualized capex is distributed over 20 years, which will come around 16.5 crore per year here, 16.5 crore per year for the capital expenditure, and total annual cost will be 16.5 crore plus 11.1 crore is 27.6 crore per year. So, when you divide again by the 3 million ton per annum production, it comes to around 92 rupees per ton. This is slightly on the higher side in this case, because our estimation is absolutely quite conservative, that we will be installing most of the things following all the rules and regulation and the standard practices or advanced practices. Usually, depending on the scale of operation, scale of implementation, it varies between 30 to 80. So, it is very close to the realistic figures. So, it is about 92 rupees here, 90 rupees per ton of ore that we have produced from the mine. So, what are the strategy that we can follow for reducing the environmental cost? Other than the cost figures, we should plan right from the beginning before installation that what we can do to reduce the cost, and also to understand what are the alternatives that we have for better mine management in regard to environmental mitigations. We can switch over or partially switch over to renewable energy like the solar and wind energy, and integration of these things with the traditional reliance on the coal or say nuclear power, that will give us certain advantages. We can also produce, because mining there are places where we can see even in India that mining companies have installed huge solar areas with solar panels. So, they are not only supplying to their own or catering to their own needs, they are also feeding to the national grid. So, that is a very good advantage. We say that we are in remote areas, we are doing mining, but how to utilize that remote area or the places where this is not used at all. So, there you can install the solar or wind energy and then contribute to the production of the renewable energy. We can go for automation in waste management like AI driven monitoring system to optimize the waste disposal. Nowadays many techniques have come. So, we can design the things properly so that you need less place and less risky waste disposal, so that during rainfall or other cases the tailing dam does not break and then does not cause havoc, environmental catastrophic. Now, you can switch over also to dry processing technology wherever possible, so that you reduce the water consumption and the tailing disposal costs. Also, we can go for capturing carbon dioxide emissions from mining operations, which can prevent penalties and also carbon taxes. This will also reduce the carbon footprint, that means the carbon tax liabilities and environmental penalties. So, these are during the design itself, before the plant or before the project is implemented, we can think of these alternatives right from the beginning. So, what happens that you not only reduce the environmental cost, you adopt the state of the art, and definitely you help in managing the environmental the cost, and you can effectively reduce the environmental cost, which is also environment friendly. With this, we come to the end of this discussion on the cost of the reduction, and we also give certain importance on the as I said before, the progressive reclamation and water cycling system, conservation of water, and I must mention also the fuel efficiency by using certain sensors. Also there are many companies which are using latest technologies through IoT enabled operations. So also the automation compliance monitoring means that certain sensors will always say beforehand that what are the things going to happen. So the emission levels can be easily monitored from remote locations. This will help in reducing the environmental cost, and also the ethical part, that means we must reduce the environmental harm. So the not only the cost, but we will be doing these things for the benefit of the society and the habitats around the mining areas. We have taken these the most of the references from this the references that we have seen, you are seeing here. Also the Ministry of Mines website also gives lot of information, and very renowned contractors or consultants, the international consultants, from there also we have taken the figures. So you can go through these pages once again, and on your own interest you can ask for a design of a certain hypothetical project, and understand what could be the figures that is relevant for that project. This is a good process of learning. So thank you for being with us. Thank you very much. See you again.